Hi, my name is Amil Ahmed Sofi. Today I am going to teach you a very important topic of chemistry, and the name of the topic is nomenclature of coordination compounds. So let's begin. So we have generally or most common two types of coordination compounds. Let's see. We can represent them in two ways. One is like this. You write coordination sphere here, central metallic atom plus ligand, and then counter ion. So this is one way of writing coordination compounds. Another is like this here. Counter ion is here, then coordination sphere, central metallic atom plus a ligand. So these are the two ways how we represent coordination compounds. Now first part, we have main two parts, this coordination sphere and counter ion. Always we give positive sign to first part, that's on the left hand side, and negative sign to the other part, that's on right hand side. So this part is left hand side, we give it a positive sign, here we give it a negative sign. So here I will give on the left hand side is positive sign, so here positive sign, here negative sign. So this is the first thing we can do. Now let's see, we have main three parts here. One, central metallic atom, two, ligand, and counter ion. How to name them? First we have to think, the rule is we should start from left to right. And we have here three parts, central metallic atom, ligand, and counter ion. Which part we should give the name first? That's the question. So I am telling you what we will do. We will cross it like this. So ligand will come first, central metallic atom will be the second, and counter ion would be the third. I will give them naming. This is the first part, it is the second part, it is the third part. So in this way we can give them name, first ligand, then central metallic atom, then counter ion. So it is here for first type of coordination compounds. Now let's see here. Counter ion, you bring an arrow down. So it is like this. Only these two parts are crossed. So I will bring it here. So now this, let's see. So this is the counter ion. It is ligand. And this is central metallic atom. Now this is the first part, second part, and the third part. So this way we are going to give them name each part, but we will start from left to right. When we know how to name ligands, then it is easy to give name to whole coordination compound. First of all, I will write some types of ligands. So I will write some types of ligands. I will pull it up, scroll it up. So it is like this. Now look, we have three types of ligands: neutral, then anionic, which carries negative charge, then cationic, which carries a positive charge. So these are three types of ligands: neutral, anionic, and cationic. The neutral, I will give some examples for each. Suppose NH3, it is called amine or amine. Another one is H2O, we call it aqua. and then CO, it is called carbonyl. NO we call nitrosyl, and one more I can write CS, thiocarbonyl. So these are the neutral ligands. Now let's see here, keep it in mind, IDE in compounds is replaced with O. For example, we have Cli, Cl negative. So generally we write it chloride, but here we will write it chloro. Chloride, last RIDE is replaced with O. So chloro. Instead of chloride, we write chloro. Now here we have minus H ion. It is called hydro. Another ion is SO minus 2. It is sulfato. I will give some more examples. NH2 minus 1. So it is amido. Another one I will write here. NH minus 2, it is amido. Here N minus 3, azido. O minus 2, that is oxo. So these are some anionic ions. Anionic means which carries a negative charge. Now let's move there. Here we change ending word like this. We use IUM. So for example, I have NO positive. We name it this part nitrozonium because it ends with IUM. Another one is NO2 plus nitronium. So this is one more. NH2, NH3 minus, so it is called hydrazinium. So these are few examples of cationic anions. Now let's move ahead. We will give name to some ligands, naming. So I will give an example here. I have K4 FeCN6. This part is the ligand part. How to name this? What I do, the number it is carrying, this is the 6. So I will bring it first. Then ligand would be the second. So this is 6. Instead of 6, we write hexo. So I will write hexa. Hexa, then we have cyano. Hexacyano. So this is the way how we name. We first give name to the number, whether it is tetra, it is hexa, whatever it is, and then we give name to the ligand. These parts we will mention and discuss later. Here I will give you one more example. For example, we have CrH2O, it is 4 times, Cl 2 times, and NO3. So here, what is ligand? It is central metallic atom. It is counter ion, NO3. Here ligand, I have 2 ligands this time. It is not only one ligand, I have 2 ligands. So now, which ligand I should name first? Because as a rule, I have to name the ligand. But we have 2 ligands, how to name them? What I will do? I will follow alphabetic order. Suppose it is called aqua. And this is called chloro. So alphabetic order, alphabetic order. So what alphabetic order I mean to say, which ligand I should give the name? In alphabetic order, A comes first. So here is A, C comes later. So we will give name to the part which has lowest alphabetic order. So here I can write this ligand. First I have to name this part, that is, it is 4 times. So I will write tetra, then this aqua ligand. So this is done. Now let's move to this. It is having 2 times chlorine. So 2 means di, and chlorine means chloro. So this is the case when we have more than one ligand. Now I have given you the rule how to name the ligands. Let's move to the main topic, that's how to name the coordination compounds. We will talk about few examples, then we will move. Naming coordination, final topic, that is naming coordination compounds. The first example I have given, for example K4, CN 6 times. So this is the coordination compound, how to name it. First we have to see, this is the counter ion, it is outside the sphere, this is coordination sphere. So I will bring arrow down. So this is the first part I am going to name. Here in coordination sphere, we change their position. Suppose this ligand will come here and this Fe will come here. Now let's see. One thing I have already told you, that first part should be the positive, second part you will give negative sign. Now this is the first part, I will write potassium. Tetrapotassium, it is not used here with counter ion. Counter ion is outside the coordination sphere. So we just write the name of the element only. So potassium. Now after this we need to write the name of Cn, but it is 6 times. So I will write hexa cyan. So I have named this part. Now there remains last part, that's iron. I will write ferrate. Ate we add at the end when central metal atom is carrying negative charge. Here it is coordination sphere has a negative charge, that means this central metallic atom part is carrying negative charge. For that reason we add at end ATE. So ferrate. Now only one thing remains, that is oxidation state. We should know what is the oxidation state of central metallic atom. I will give you an idea how to count that. We have 4 potassium, oxidation state. So 4 times potassium, 4 potassium plus Fe plus 6 times Cn. So now we know that oxidation state of potassium is positive 1, Fe is like this, plus it is oxidation state Cn is, that is negative 1. So 6 minus negative 1. We have to make it equal to 0. We have to compare it with 0 because overall this compound is neutral. So negative positive cancelled, so it is neutral. So we give its value is equal to 0. Now, sorry, I have written here K, instead I should have written here. This is a mistake. So I will erase it. It is 4. It is 4. So 4 into 1, 4 positive charge plus Fe, 6 into 1, 6 plus this is minus, so minus 6 is equal to 0. Now I will transfer 6, it will become plus, and plus 4 when I will transfer, it will become minus. So Fe comes out to be 2. So this is the oxidation state of iron in this compound. Now at the end we have to write like this. So this means this iron atom has oxidation state 2 and we mentioned it here. It is one example of naming coordination compounds. Let's take one more example. We have Ag, Eg, NH3 2 times and Cl. I want to name this compound. What I will do first, this is the positive part, it's negative part. I will name first ligand. You know that first we name this part, then this part, and it will be the last one. So ligand, for ligand we have, it is 2 times amine. So I will write diamine, diamine. Then this silver atom, silver. Now we should also know what is the atomic oxidation state of silver. As I have already calculated, it is 1. So silver 1. Then finally we have chloride. Chloride. You may ask me, sir, why don't we write it chloro? Because it is not inside the coordination sphere, it is the counter ion. So for counter ion, we generally write the chloride, something like that. So it is done. Now one more example I would like to give you. Here I have already given one example, I will give that again. For example, we have this element, we have H2O 4 times, Cl 2 times, NO3. Now how to name this? 2 parts we have, it is positive, it is negative. This coordination sphere we consider positive, this counter ion is negative here in this case. Now we have, as I have already mentioned, 2 ligands. First we need to give name to this because in alphabetic order aqua comes first. Then to this ligand, then this. So it will come here, these 2 will come here and it will come down. So first I will name these ligands, but ligands I will give H2O first, that is aqua in alphabetic order. So it is 4 times. I will write tetra aqua. So tetra aqua done. Now chlorine is 2 times. So I will write dichloro. So it is done. Ligands 2 are done. Now chromium. Chromium. But chromium is 3 times, having 3 oxidation state. We can calculate its oxidation state is 3. And it is done now. Now we have this last one, that's nitrate. Nitrate. So it is another example how we name the coordination compounds. Let's move another part. I will show you here. Cr, NH3 5 times, NO2, Cl2. So how to name this? I will name it very quickly. In alphabetic order, this ligand will come first, then this. So it is 5 times. Chromium would be named later because we cross them. Now it would be pentaamine, then this nitrito, this is called a nitrito N, this ligand. Then we have chromium. Chromium, it is having oxidation state 3 here again, and chloride would be at the last. So it is one more compound where we have given names according to the rule. So I hope you enjoyed this topic today, how to name the coordination compounds. Thanks for watching.